Hello, we're going to start chapter 2. The first section is different ways to tell if something is a function or not, and different ways we can represent a relation. So the first type of problem that we're going to talk through is what are 4 different ways to represent a relation. So the first example I have for you is I have these different ordered pairs, and this is one way that you can represent a relation is just ordered pairs, so that the first value is our x value, the next number is our y value. So this is one way that we can represent a relation. A couple other ways that we can represent a relation is have these next couple methods. So one way is by mapping. Mapping, instead of saying x and y, I put input and output. Input and output means the same thing as x and y. So in the mapping relation, every x, we draw an arrow connecting to the y. So like this first coordinate was 0 and then 10,000. So I made an arrow connecting the 0 to 10,000. The next one was 4 and then 9,744. So the 4, I made an arrow to 9,744. So that would be mapping when you make an arrow connecting the x value to the y value, or the input value to the output value. Another way we can represent this is making a table. So the table, instead of saying x and y, maybe my x is my time in seconds, and then maybe my y value is my height in feet. And then I just put my x values here, my y values here. So that would be a table. And then the fourth and final way to represent a relation is by a graph. That I have my x values down here, so my time. I have my y values over here, which is my height, and then I plot these coordinates, so that would be a different way. Now the nice thing, depending on what the follow-up question is that they're asking, it might be easier to have it in a certain way, so either ordered pairs or mapping a table or a graph. Alrighty, the next question or type of problem that we're going to talk through is, once we're looking at a relation, how can we tell what the domain and range is? So the easiest way to tell is if it's in the form of coordinates. So if I give you the same coordinates, the domain is just what are the x values. Range value is just what is the y values. So in this problem, our domain would be 0, 4, 8, 12, and 16. Again, that's just the x values, the first number in each of the ordered pairs. Now range is the y values, so we're listing the second number in each of these ordered pairs. Alrighty, this next example that I have for us, again, I'm giving it to you as ordered pairs, and then I want to know what is the domain and the range. So the domain, our x values would be the first number, so -3, 0, 2, 9, and 23. You can put it from least to greatest, that's what the textbook is going to have, but I don't care either way. Just make sure you list all the numbers. And then the range is your y value, so the second number, so 14, 7, 0, -18, and -99. Alrighty, the next type of problem we're going to talk about is some different ways to tell if something is a function or not. So I have this mapping for my first example, and notice how this -3 goes to -2, 0 goes to 7, and 4 goes to 1. I want to know, is this a function or not? So if it's in the form of mapping, the easiest way to tell is for every x, it can only go to one y. So this -3 only goes to one y. This 0 only goes to one 7. This 4 only goes to one y value. So for every x, it's only going to one y. So it would be yes, a function. So we would say yes, this one is a function for every x. It is only mapping to one y. So let's try another one. Now this one is in ordered pairs. So if it's in ordered pairs, instead of putting it in mapping, another way to tell if it is a function or not is look to see if there's duplicate x values. So our x values are our first numbers, and I want to see, are there any duplicates? So notice here I have a 4 and here I have a 4. Since I have duplicate x values, then it is not going to be a function. Okay, this next one I have mapping. So I could write these as ordered pairs. So 2, 6, 2, -3. I would have 3, -1, 4, 3, and 6, 6. And then I could see if I had duplicate x's. Or I could do the method that I showed you for this first problem. For every x, it can only go to one y to be a function. Notice this 2, though, goes to 2 different y values. 2 is mapped to -3, and 2 also goes to 3. If I write these as coordinates, I have duplicate x values. So it is not a function. Or I can see for every x, it doesn't just go to one y, so this one is not a function because of this 2. Alrighty, now this next one, if they instead give you a graph, instead of writing the coordinates and doing it like the above methods, I would do the vertical line test. So if I gave you this parabola that's on the side like this, I would do the vertical line test. And if anywhere I make a vertical line, if it crosses at more than one place on my graph, then it is not a function. So this one crosses up here and it crosses down here, so it is not a function. So let's try this number 5. Okay, so if I make a vertical line anywhere on this, so let's say I make it right here, notice it only crosses at one place, so it's a function. If I would move my vertical line over here, it still only crosses at one place. So regardless of where I move that vertical line, it's only crossing at one place, so this one is a function. Now, this last problem, I'm going to use function notation for. So I'm giving you this t-chart, and they're just going to give you the x values actually, and they're going to want you to solve for the y values. So if the problem looks originally like this is function notation. Now don't let this throw you off. This f of x is just the same thing as y equals. So if you want to replace that f of x with y, you can. So f of x equals -2x plus 5, or you can have y equals -2x plus 5. Now they're going to give you a list of x values, so you're just going to replace that x with -3, 0, and then 4, and you need to solve for this y. So if I start off with plugging in -3 here, and I simplify that down to order of operations, I would multiply first and then add. So 6 plus 5, I would get 11. So then that's how I'm getting that 11 over here. If I do the next one, if I plug in 0, so -2 times 0 is 0, plus 5 is 0 plus 5, which is 5. And then the last one, if I plug in 4, -2 times 4 is -8, plus 5 is -3. That these then are my y values. Okay, and again, that's called function notation. Don't let it confuse you. It'll come up throughout the school year. Sometimes they'll use f of x or k of x or h of x. It doesn't matter which variable that they use. Just think of it as y equals. It represents the same thing.